Hi guys, welcome back. Today's problem is the codify friends recommendations. Okay, so we have a listen table with user ID, song ID, and day. This table doesn't have any primary key, which means one of those rainy day and you just have one song on repeat. Alright, so that's basically how I describe this table. We got a friendship table where the column name is user 1 ID, user 2 ID, and the tuple of this, meaning a combination of this, is a primary key. Each row of this table, indicates that user 1 and user 2 are friends. Note that user 1 ID is always less than user 2 ID. Okay. Recommend friends to Leetcodify users. We recommend user X to user Y if user X and Y are not friends. So that's one of the conditions. User X and Y listen to the same 3 or more different songs on the same days. So if user X and Y just have one song on repeat, that doesn't mean anything, right? Note that friends' recommendations are unidirectional, meaning if user X and user Y should be recommended to each other, the result table should have both user X recommend to user Y and user Y recommend to user X. Also, note that the result table should not contain duplicates. So if they listen to more than 3 songs, that there's chances are the tuple will show up more than once. Basically, that result table in any order. Here's the examples. Okay. So you see song ID 10, 11, 12. So let's say these two listen to the same 3 songs, also as number 3 on 315. And then 4 dozen and 5, it just listened on a different day. And so the friendship table has 1 and 2. 1 and 2 are friends already. And so the recommendation is like 1 and 2 should be friend with 3. Same thing with 3 and should be friend with 1 and 2. Anyway, the acceptance rate for this problem is quite low, but here's so let's dive in. Please note that I've solved this problem before, just right before this, so I'm just gonna reiterate my thoughts for you all. Right, so when so basically we're going to do a cross joint and we're going to join the day for sure and the song, so using the day and the song as an anchor, and see if user 1 listen to it and use and then we're going to pair, we're going to have a pair of listener number 1 and listener number 2. And then we just remove anyone that has the same is already friends. So that's called a self join. So we're gonna do a select. So we're gonna join 2 table. Listen number 1, user ID, and L2 user ID. We're gonna call this, it's already a user, we're gonna call it recommended ID. Okay, from listen table number 1, L1, we're gonna do a join with L2 listens L2 on. So here's the thing. So it has to be on the same. So here's the thing. Here is the conditions. So on the same day. So we're gonna join this on this day. So L1 has to be the same day with L2 and the same songs, right? And the same song, and L1 song ID has to be equal L2 song ID. And the third one is like we don't want to get like the same user, right? Because we do a self join and it's the same day, it's the same song. It's gonna give me the same user, so it's gonna give to user ID is not equal to L2.user ID. All right, so now we get a table with like user 1 and user 2 with, you know, the same day, the same song, that listen to the same song on the same day. But we also have this condition where listen to the same 3 or more different songs. So we have to do a filter, but since we are aggregating this filter, we're gonna do as having count. Remember the distinct, because you know, let's not count those who listen to the same song on repeat. Distinct song ID with larger than 3, and if we have count, we have to have group by, and we're going to group by the whole L1 user ID, L2 dot user ID, and also the day, right? We're going to group by the day. And so just one, it's the same day anyway, so we're just going to group by that day. Alright, so that would give me a table of user number 1 and user number 2 that listen to 3 or more different songs on the same day. Alright, so now we have to incorporate in the user 1, X and Y are not friends. So we could do so instead of union, we can do a minus, we can do a set operator, right? So we already have, so we're gonna minus select everyone. In the friendship table. Right. Let's just run it and see. I think this should be okay. Column ambiguously defined. Now one user, which one? Column ambiguously defined as recommended ID. Recommended ID. Sounds ID, user ID, count song this. Oh, maybe this one. L1. That's song ID. Okay, run this. Okay, it's a wrong answer, so let's see why are we wrong. 1 and 3. pay attention because its expected result is not even the output per se, but let's compare this one and this one. So 1 and 3, 2, 2 and 1 are also friend in the friendship table, right? But we have it backward. Okay, so let's just minus one more and select. So we're gonna do the backward user 2 ID and then user 1 ID from the friendship table. Notice that SQL is just gonna line them up and then remove things. And so even if the name is kind of different from these two, right? But we line them up the first column to the first column and they remove any of the duplicates. Okay, so now we're running this. And you see this thing is right with this one. So let's just submit.